Good morning everyone. The last lecture was the introductory lecture, but the actual topic starts from the concept of wavefront and wave normal. The concept of wavefront and the wave normal was introduced by the scientist Sir Christine Hygiene to explain the phenomenon of reflection and diffraction. So first of all, let us consider what is meant by the wavefront. Okay, for that purpose, let us assume here at the center there is a source of light is kept. The source of light is placed in the homogeneous medium, for example air, and assume that the velocity of light in air as c. Okay, so as this is the source of the light, then this light source emits the light waves in all the directions. Actually, I have just shown the 4 directions for the sake of convenience, but the source of light emits the light waves in all the possible directions. Now, tell me, during the time interval of t, how much distance will be covered by this wave which is coming out from the source S. So for that purpose, we know that the relation velocity is equal to distance upon time. So in order to find the distance, so distance is equal to velocity multiplied by time. But here the assumed velocity is c. So this wave travels a distance of c into t, okay, and reach at this point. Similarly, this wave, this third wave and the fourth wave, all these waves covers the same distance and they reach to these points. Okay, after connecting all these points, a sphere is formed, and such a kind of construction is called as spherical wavefront. Note that in the case of wavefront, suppose this is a point A, this point is B, then these 2 points have the same phase. Why it is so? Because these waves covers the same distance and they reach to the points A and B. So the very important point in case of a wavefront is all the points on a wavefront are in the same phase. So if anyone asks you what is the phase difference between the point A and the point B, then your answer will be the phase difference between A and B equals to 0. Okay. Now this wavefront is spherical in shape, so it is called as spherical wavefront. There are total 3 different kinds of wavefronts: spherical wavefront, plane wavefront and cylindrical wavefront. The simplest example of the wavefront is, suppose you throw a pebble in a lake, then the water waves are produced, then the ripples are produced which are spherical in shape, and that is the best example of the spherical wavefront. Wavefront roughly means the front part of the wave. Okay. Now, the next concept is of wave normals. Wave normals are the perpendiculars which are drawn to the surface of the wavefront. Here, the black semicircles are nothing but the successive positions of the wavefronts, and these red arrows are nothing but the wave normals. These arrows means wave normals are perpendicular to the surface of the wavefront. In other words, we can say that the angle between the wave normal and the wavefront is equal to 90 degree. The wave normal represents the direction of the propagation of the light, because our wavefront is propagating in this direction, in the forward direction. So these waves are also, these wave normals are also along the direction of propagation of the light. Wave normals are nothing but the rays of the light. So this is the successive position of the spherical wavefront, and these are nothing but the wave normals for the spherical wavefront. For the spherical wavefront, the wave normals may be diverging. These are the diverging wave normals. Or for the spherical wavefront, the wave normals may be converging also. Okay. Now, the second figure explains the plane wavefront. So, in order to get the spherical wavefront, the condition is that the point source of light S must be kept at a finite distance, at the measurable distance. So, a point source of light at a finite distance produces the spherical wavefront. For example, the light bulb in a room produces the spherical wavefront. Now, in this diagram, these black vertical lines means the plane wavefronts or the successive positions of the plane wavefronts, and these red arrowheads or arrows are nothing but the wave normals. Okay, here also these wave normals are perpendicular to the wavefronts, means angle between the wavefront and the wave normal is equal to 90 degree. Now in this diagram, the source of light is not shown because the plane wavefront is formed due to the point source of light which is kept at an infinite distance. So the source of light is at an infinite distance, so that source of light is not shown in the diagram. The example of the plane wavefront is the light rays which are coming out from the sun and reaches to the earth's surface in the form of plane wavefront. Again, there is another method to produce a plane wavefront is by keeping the point source of light at the focus of the convex lens. Okay, so this is the spherical wavefront and these are the wave normals, and this is the plane wavefront and these are the wave normals for the plane wavefront. For a plane wavefront, the wave normals are parallel to each other. Again, there is a third kind of wavefront also, which is called as cylindrical wavefront. Cylindrical wavefront is cylindrical in shape, so termed as cylindrical wavefront. For example, if there is a linear source of light or the extended source of a light, for example tube light, then the wavefront which is emitted by the tube light is nothing but the cylindrical wavefront. Okay, so the wavefronts are classified according to their shapes. Okay, now we are moving towards the next article, and this article is the basic building block of this chapter, which is nothing but the hygiene's principle. Very important article from the chapter, and you have to by heart all these 3 points, which are nothing but the statements of the hygiene's principle. Okay, so once I read these 3 points and then I'm moving towards the hygiene's construction. Okay, so the first point is every point on a wavefront acts as a secondary source of light and emits secondary waves in all the directions. Okay, the secondary waves travel with the speed of light in the medium, means of c, 3 into 10 raised to 8 meter per second, and are effective only in the forward direction. This line is important, are effective only in the forward direction. And finally, the tangent drawn to these forward going envelope gives the position of the new secondary wavefront. Okay, now these 3 points we are going to understand with the help of these 2 diagrams. Okay, in examination there will be a question for 3 marks or 2 marks that explain the construction of spherical wavefront with the help of Hygiene's principle, or construction of plane wavefront with the help of Hygiene's principle. Okay, Hygiene's construction means a construction in which Hygiene's principle is used to construct the spherical wavefront and the plane wavefront. The construction of cylindrical wavefront is beyond the scope of the syllabus. Okay, so first of all we see the construction of spherical wavefront. Okay, so for that purpose let us consider a point source of light which is kept at an finite distance into the air medium, into the homogeneous medium. So this S, so from the source of light S, light waves are emitted and these light waves reaches to the some points in the medium. So consider this P, Q and R, this middle semicircle. Okay, this middle semicircle is termed as the primary wavefront which is produced by the source of light, for example at t equals to 0. So if the nature and position of the initial wavefront is known, then we can construct the wavefront, the similar wavefront at any later instant of time. पण जर मला सुरुवातीला तो टाइम माहिती असेल आणि सेकंड म्हणजे तो कुठल्या काइंडचा वेवफ्रंट आहे तो माहिती असेल तर मी न्यू सेकंडरी वेवफ्रंट कन्स्ट्रक्ट करू शकते. ओके, सो दिस S produces the primary wavefront PQR which is spherical in shape. Okay, now look at the first point of the principle. Every point on a wavefront acts as a secondary source of light and emits secondary waves in all directions. Okay, so या वेवफ्रंट वरचा प्रत्येक पॉइंट आपण आपल्या सेक ऑफ कन्व्हिनियन्स साठी फक्त 3 पॉइंट्स दाखवलेले आहेत. तिथे नंबर ऑफ पॉइंट्स त्या वेवफ्रंट वरती असू शकतात. सो नाव दीज 3 पॉइंट्स P, Q and R acts as a secondary source of light. Now as these are the secondary source of light, so they emit secondary waves in all directions. Actually the backward rays are ineffective, so these waves are not shown here in this diagram. So by assuming the second point, the secondary waves travels with the speed of light in the medium in the forward direction, means from P to P dash, from Q to Q dash and from R to R dash, moves with the speed of light and are effective only along the forward direction. Okay, now on assuming this P as a center and CT as the radius, if we draw the spheres, okay, so here the spheres are drawn by considering those assumed points as their centers and the distance as CT, because we are going to find the new spherical wavefront at time t equals to t. So this distance, obviously distance equals to velocity into time, so distance equals to c into t, and this is the final position of the secondary wavefront. Means when we draw the tangent to these spheres, this tangent or this envelope means the position of the new secondary wavefront. Okay, so this is all about the spherical wavefront. Similarly, we can explain the plane wavefront. Again, the point source of light is not shown here because for a plane wavefront, the point source of light must be kept at an infinite distance. Okay, so that source of light produces this primary wavefront at time t equals to 0. Okay, now assume the 3 points on a primary wavefront P, Q and R, and according to the Hygiene's principle, every point on this primary wavefront acts as a secondary source of light and emits the secondary waves in the forward direction. Okay, so again, by assuming these points as the centers and the distance CT as the radius, draw the spheres and finally draw the tangent to these spheres. So this tangent drawn to the spheres gives the position of the new secondary plane wavefront. So plane wavefront, primary plane wavefront gives rise to the secondary plane wavefront. Okay, thank you.